Hello everyone. This is gonna be Cubstart lecture number 7. Unfortunately, I've been dealing with some fevers, so the lecture is gonna be shorter this time. Um and yeah, so Cubstart Web lecture number 7. Some administrivia is we have homework 5 due tonight. Homework 6 is due next week. And homework 7 releases tonight and is due in 2 weeks from now. Um, let's do a quick recap of some of the things that we've seen so far. So far we understand what HTML is, how through CSS we're able to make our websites a little bit more look a little bit nicer, and how when we add JavaScript we're able to make them interactive. We've also established so far the distinction between the front end, which is the code that is run on your computer, and the back end, which is basically like the code that is run on servers. And we can see how, for example, in the Instagram scenario of like whenever you look for Instagram on your web browser and you get served the front end code. And then based on the front end code, you're able to log in and you send your credentials to the servers of Instagram, and they're able to authenticate that you are who you say you are. And they send back like your feed, the posts of your friends and all of that. But there's still a missing piece in order for us to be able to create a large scale website. And that is that we need a database in order to be able to manage and store data over long periods of time. So far, if we close, what we built so far is if we close our browser and we open our page again, our data is not going to be there. It's going to restart because so far we've saved the state of our application in the web browser. But if we want to save some data and be able to close our browser and come back, we need to store it somewhere else. And that's why we're going to need a database. So again, it is a place where we store and organize data. We use them to save and retrieve data easily and keep it organized and secure. Again, Instagram, you log in and Instagram has all your information, the logs of your chats that you've had with your friends, and it's secure because only if you give them the correct credentials, they would actually give back like that information back to you. Um, there's also different kinds of databases. Because different types of databases store different data. Mainly we have relational databases. They organize data into rigid structures called tables. So you have tables, let's say a table of users, and it's gonna have username, user ID, and a lot of information that is sort of like appended to the user. Um, We can use SQL statements to combine and query from these tables. For example, with MySQL, SQL Server, and SQLite, these are database management systems that are SQL based. SQL is a language that basically functions into a relational database. We'll see a little bit more of what this means. We also have NoSQL databases, and that is basically they organize data in some other way. The thing is, the standard in software engineering is to sort of like store your information through an SQL model, which is a relational database. So they basically separate databases into, okay, this is SQL and this is an SQL database. And there's many management systems that enforce this. this protocol of SQL. There we have MySQL, SQL Server, SQLite, Postgres SQL, and then we have NoSQL databases, which is MongoDB and many other databases, basically. Um, so yeah, again, we have SQL, they're relational, they're mostly tables, and then we have NoSQL. They can be graphs, they can be documents, key values, many different things. Um, One example that I can give you guys so you can sort of like feel a little bit more of this difference between databases is we have like your typical database, which is like a table and has information. I mean, back in the day, they used to use Excel in order to store data about a company and all of that. You can see it in that way. That is SQL. Right now, something that is very popular is called vector databases, and they're used for AI. Let's say what this vector database does, it takes either a text, an image, an audio, or a video, and it transforms it into a vector, and based on that vector, it is able to store it in a vector database. And you might think, why is this useful? It's because let's say that you input um you input a bunch of you have a company and you want to use AI in order to be able to find valuable documents that you need to use in they have like important information about your company. So what you do is you transform these documents into vectors, you insert them into your vector database, and whenever you want to find an important specific like piece of information within like your thousands and thousands of documents, you write a prompt. The prompt is transformed into a vector and it matches into the vectors look that transform and are the closest to your documents, so it's able to find rapidly information within thousands and thousands of documents based on one prompt. So in this case, it is a little bit more complicated, but it is definitely like storing vectors is definitely like not your typical SQL way of storing information in a database. But yeah, relational database organize data in different tables. Each entry of data is basically in a row, and this row has to have a unique ID called a key, which we can use these keys to relate rows in separate tables together. So a key that uniquely identifies our own table is called our primary key, and a key that uniquely identifies another table is going to be called a foreign key. Um, I think we have an example very close here. Um, so relational databases, this SQL model requires specific schema. So if you say my table is going to have these specific fields, let's say like username, age, nickname, gender and stuff like that, you're gonna have to comply with that schema. So whenever you enter another row, you have to enter information for every field unless you specify that one of those fields is optional. Um, and this is an example. I think this is like better with an example. So if you see here, we have a table. This is like a database, and we have multiple tables. We have users, replies, and posts, and favorites. Um, in this case, the users are gonna have a primary key, which is gonna be a unique way to identify a row. You cannot have duplicates in the primary key. So in this case, people, let's say in this table, are allowed to have the same username, but their ID that is going to identify each entry of the row, each row entry, this is going to be different. And here we have users. We have username, email, date created, And then in the table of posts, again, we're gonna have a primary key that is gonna be the ID. It's gonna be unique. There's not gonna be duplicates in the primary key. But then we have this thing called foreign key, and it's gonna say user ID. And what this foreign key basically does is it references to the primary key of another table, in this case, users. So in this way, what this is saying is every single entry of a post is gonna have a unique ID, and it's gonna have another ID that is going to reference a user in the users table. So this we're basically saying this is um I forgot the word. It's this is a contract that is saying you can be completely sure that this is going to reference a user in the user table. And then we're going to have a content string that is going to have like the content of the post and then date created. Then again, we're going to have a primary key here. There's going to be an ID of replies to a post. And then replies to a post, they're going to reference two other tables because, a reply, whenever you have a reply, replies have to be tied to a specific post. And they also have to be tied to a specific user that is making that reply. So again, we have two foreign keys in this table, and they're going to reference in this case, going to reference user and is also going to reference the post ID. So what is SQL? SQL is basically just a language that you use to talk to a relational database. Um, you can use basically certain queries with different keywords to select certain columns, filter rows, and join tables together. For example, if you have a table called users, you can select everything from the table users, where in the column age, everyone is above 18. And this query will give you back all the rows that comply with this filter from the table users. Um, what is a NoSQL database? They don't, the thing about NoSQL databases is that simply what they're telling you is that they don't format their data into a strict schema with tables like in an SQL database. This encompasses a lot of database models like the vector database that I mentioned before. Um, we also have like graph databases. We have JSON object databases like MongoDB, and we also have key value pairs like Redis cache. So usually SQL is better for relational data like social networks. You have to use a predefined schema for your data because you're going to have tables and they're going to have columns. And for every row that you insert, you're going to have a valid field into the schema that fits the schema. It can be a little bit harder to design and use, but it is better at scaling the more tables you start adding, and this can really help your app sort of like maintain control of the structure and flow of the data. NoSQL databases, they specialize in different type of things. It really depends on the use that you want to give them. Some like MongoDB, they don't have like a great use case, but they can handle dynamic schemas and they're generally easier to use. Um, so we have MongoDB. MongoDB is a type of NoSQL databases. It organizes your data in a more flexible way. They're basically like objects, and you can store them. You have like this JSON objects, and that's basically what you store in your database. In the MongoDB model, you have a database, and within the database, you can store multiple collections. A collection is somewhat like tables, and within those tables, you can store multiple documents. And documents is simply a JSON object representing one piece of data. So each key value pair in the JSON object is going to be called a field, and we'll see an example. For example, here we have a JSON object, and this is like the document that you're going to insert into your collection. This can be an example document found in collections users in a database called Facebook, for example. So we have a database. The database is going to be called Facebook. Within this database called Facebook, we're going to have a collection called users. And within the users, um, we're going to have a document, which is going to be basically like a record. In this case, this one, JSON. And just like here, where we say that in the document, we're going to have a key value pair in the JSON object called field. The document is going to have a field called name. This is going to be the key, and the value is going to be Jesse. Age is going to be the key. The value is going to be 21. And then the hobbies is going to be the key, and an array of the values that are basically like the hobbies is going to be, well, the value. We're going to have drawing and coding. And sorry guys, I'm just like I've been dealing with fever. But yeah. Um The MongoDB database can contain one or more collections. So this is basically like your tables. You're gonna have multiple collections where you can store different types of data, and you can like within a collection you can store multiple instances of documents, which is basically going to be your records of whatever is in that collection. So to make a MongoDB instance in the cloud, you're gonna have to go into this page, MongoDB. This is a software as a service platform that allows you to have like a database in the cloud. So this way, whenever you have a website and you store information in your database, if you close your website and you open it again, you're going to be able to fetch the data from this platform. So I'm not going to be able to do the demo right now because I'm pretty sick, but I found a very useful video that walks you through how to create your MongoDB account, create your database, and how to create it for free, and be able to connect to basically create a database and connect to it. And if you guys have any questions, let me know on at I'll be I'll be posting this tutorial, and thank you.